fermentation problem before it happens. It's usually a bunch of straightforward common sense type things that you have to do first, like, well, know what to expect from the yeast strain you select. Hopefully you've worked with it enough and you have a great sense of its normal fermentation profile, like how long its lag phase is, which you've actually measured repeatedly and found some consistency, or the time to maximum fermentation rate or the expected maximum fermentation rate. And lastly, how long does the max fermentation rate last? So looking at this graph here, this is basically a normal fermentation. On the y-axis is Brix, and on the x-axis is hours, and you see, basically a normal lag phase. And then the steepest part, as we come over the hump here, the steepest part here coincides with the fastest rate of fermentation. And then it basically sustains until it starts to slow down a little bit after we get a little bit below 5 Brix. The total ethanol at this point down here, is roughly 11–12%, and we've got a relatively dry fermentation at this point. Some of the problems with fermentation in this particular example, you've got, again, Brix on the y and hours on the x. And this is a long lag phase with the rate that eventually becomes normal. So I put some bullet points down here to give you a sense for what might have happened. And you could have initiated at a low temperature. You can see the long lag phase here, and then of course you can compare that to what's normal for your particular yeast. And so this long lag could be the function of again, a low temperature. But again, a low temperature is something that the yeast can recover from. It's far different than, say, if the temperature is too hot and you heat shock the yeast. That's a different story, because you can rejuvenate these guys if it's just a low temperature issue. Obviously, if there's any toxins that came in with the grapes, that's a big issue. And viscosity, referring mainly to like sugar and glycerol content, things like that could choke the microbes at first until they adapt to that type of a medium, and then they can hit their peak. Certainly a low healthy yeast concentration is usually the issue, and that's often dependent on how you apply your yeast to the fermentation. If the water's too hot, for example, if you have dry yeast and you rehydrate them, you can shock them. And that's a possibility. Or, again, something as simple as the dry yeast being past expiration is also a potential issue. Here's where you get a normal start, but the fermentation becomes quite sluggish. So in this particular case, you just have a long, slow slope, and again, there's a difficulty maintaining metabolism during stationary phase. It's probably the cumulative effect of a variety of stresses, and maybe even a mild temperature shock if you're not paying attention to it. You can look for premature yeast settling, for example, as an indicator of decreased stationary phase metabolism. So in that particular case, you may rack off the wine from the lees and then restart it. Here's one where it's just sluggish throughout the entire fermentation. Again, something happens where there's a problem with the development of biomass. And again, basically what that means is the microbes are probably missing some essential growth factors, and they just can't reach a high population density. And they certainly, have a difficult time adapting to the must itself. Something's missing, or some proportion of nutrients isn't quite right. In this particular case, there's a normal initiation with an abrupt arrest late in the fermentation. And so the possibility, again, is the main possibility is a major traumatic shock to the yeast population. So somewhere around here, there was a heat shock or something that happened that changed, and so you didn't get that nice completion of the fermentation. And so again, the yeast population is shocked, and usually that's a temperature issue. And then the Brix kind of just stays consistent. There's also issues with yeast toxins that can be more potent at the higher ethanol concentration, so they don't kick in. They're here, but they don't kick in until the yeast concentration is lower, and so is higher, and so as a result, the synergy of the toxin and the ethanol start to affect the yeast and actually kill them. So how do you predict these things? Well, YAN is one way to look at, one thing to look at, how much is necessary and when do you measure it and when do you supplement. Certainly competition, how do other microbes affect the fermentation, and of course close monitoring of temperature. And no surprise, wine chemistry analysis. And so that's, something that ETS always emphasizes. They always advocate winemakers to do a full wine panel as well as a microbiological panel to get a sense of what's in the fermentation and what you might expect over time. So again, they always say it's better to be prospective, looking forward and preemptive rather than forensic. The wine is a mess and you have to go backwards and just figure out what happened. So, again, paying attention to the basics. How healthy is the yeast at inoculation, and what's the nitrogen status? Just doing a simple nitrogen analysis. The initial sugar potential and ethanol concentration obviously is important as well. And these are all basic things. You can monitor temperature and fermentation rates, or even the amounts of competing microbes. One of the things that I do, and this isn't from a wine. This is actually from something else. But these are 16S metagenomic analyses, and you can get an entire profile of the microbes present. And in this particular case, you can get the percentage breakdown. So I can see, for example, that this particular species is highly abundant in this particular. It happens to be a jacuzzi filter. I was looking for some deadly bacteria, and but again, the point is that you could do this with wine juice, for example, and get a sense for who the major players are in the fermentation. Again, in this particular case, it's a swimming pool filter, but this type of technology is available. It's something that I have talked about in the lecture on tools to study wine microbes.